Good morning, students. Welcome back to another class here today. We have done the nomenclature of aldehydes and ketones side by side, and I have gone through many homework that students had sent me. Majority, it was good and it was all correct. Few mistakes were there, so I just thought to highlight those mistakes, maybe explain those mistakes right now. So today is 14th April 2020, and this is an online class for 12 and also improvers. And we will today repeat first the nomenclature, okay, of aldehydes and ketones. Today I'll also highlight or use other method of the naming. So first mistake which I observed, it was in this question number 15th, which is CH3, CH, CO, CH, CH2, CH3, and C2H5, and here was CH3. Majority of the students have done it correct, but some mistakes were there, like numbering 1, 2, 3, 4, 5, 6 from the side where the carbonyl group is the nearest. If you go this way, 1, 2, 3, 4. If you go this way, 1, 2, 3. So from the left will be the better option. Now we can see there's a methyl group and there's an ethyl group attached at these two carbons. So what I saw, many students writing this name as 2-methyl, okay, and then 4-ethyl, and then 3-hexanone. Now here the mistake is you are not going in an alphabetical order when it comes to writing the names of the alkyl groups. So that will be considered as wrong. Okay? Then what is the correct way? The correct way is basically this way. First you write the name of ethyl. Ethyl, 4-ethyl, 2-methyl, and then 3-hexanone or hexane 3,1. Now this is correct. Many of the students have done it correct. They have done ethyl before methyl and they have followed the actual way. But some students did this thing, so I wanted to correct it. Now, if we have to, I want to appreciate the improving students. Improving students are also sending me the other type of structures. Like if you want to make this one, 1, 2, 3, 4, 5, 6. So 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. There are 6 carbons. On 2, there's a methyl. On 3, there is a carbonyl, right? On 4, there's an ethyl. So ethyl has 2 carbons, so we can make it like this and this. So 1, 2 carbon. This is the structure of the same compound, but in this way. I hope you have understood this and you have understood how to draw such structures for these compounds. If you make just one line, that's a methyl. If you make it like this, it's an ethyl. You can the same can be applied in the ethers, and in ethers it looks even better. Okay. For example, if you wanna write 3-methyl, okay, and for example, we have the name of the ether as 3-methyl 2-ethoxy pentane. Right? Now, again, you can make simply 5 carbons. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 2 has ethoxy. So that means there's an oxygen and then 2 carbons attached to it. 3 has a methyl. So this is 3-methyl 2-ethoxy pentane. All right. So it's very simple. In case if you have a diethyl ether, and if you want to make that one, so 1, 2, 1, 2 to oxygen, then 1, 2. This is the structure of diethyl ether. So you can also draw these structures. I don't want you to draw these structures like it's not compulsory, but if you want to enjoy drawing these structures as well, you should give it a try. So this was one mistake in the naming of ketone, which I had to explain. The other mistake came in the third question, where the name was the third question, and it was part 25. It was methyl tertiary butyl ketone. Methyl tertiary butyl ketone. There was just one student, I don't remember who. So now, in that case, you need a tertiary butyl. So you know, this is how you make tertiary butyl. Right? This is 1, 2, 3 tertiary carbon. Then you need a ketone. This is ketone. And then in the methyl. This is methyl and tertiary butyl ketone. So ketone means you need another carbon with a double bond with oxygen exclusively. Now this is methyl tertiary butyl ketone, and if you want to name it via IUPAC rules, then you have to go like this: longest chain, number the chain, right? And it is, my friends, 3, 3. Be very careful with the hyphens and commas. Dimethyl and butane 2,1. So this is a way, and if you want to make this structure with this kind of shape, then 1, 2, 3, 4 carbons. 1, 2, 3, 4. 1, 2, 3, 4. Now 2 has a double bond oxygen. 3 has 2 methyl. So like this, right? If you go like this, then it's going to be ethyl. The 2 methyl, we can make it like this. These are the structures for this ketone. So in aldehydes, there were actually no mistakes, and rules were followed. But again, ethyl before methyl, bromo before chloro, that should not be forgotten, whether you're naming alkanes, alkenes, or you're naming aldehydes or ketones. One question came from Mahinder, which I wanted to answer here so everybody can understand this. Now, let me draw a structure that he sent me. This is a benzene ring, right? And then 1, 2, 3, 4, and then like this. Of course, this is an aldehyde. No, but what is the name? So 1, 2, 3, 4, 5. Sorry, one carbon, 2, 3, fourth carbon. Fourth carbon is bonded to a benzene ring. 1, 2, 3, 4. So the name will be 4-phenyl, okay, butanol. Because benzene's derivative, when attached somewhere, it's called phenyl. So I think it's clear. It's very easy. 4-phenyl butanol. If you make these 5 carbons, 4-phenyl pentanol. And if you make more phenyls, that so on and so forth. One common aldehyde with benzene is benzaldehyde. Benzaldehyde. It's where benzene ring is attached with an aldehydic group. Carbon, double bond oxygen, and H. Right? You can also make benzaldehyde as benzene ring, attached to CHO. That's also benzaldehyde. So with just 1 carbon, it's benzaldehyde. With 2 carbon, then it's going to be ethanol. So 2-phenyl ethanol. With 3 carbon, 3-phenyl propanol. With 4 carbon, 4-phenyl butanol, and so on, so forth. So this is the simple aldehydic benzene. Now I must tell you simple ketonic benzene. The simple ketonic benzene is acetophenone, which you have seen before, where benzene ring is attached with carbon double bond oxygen and CH3. Now this, my friend, is ketonic. This is aldehydic. As you know, ketonic. This is acetophenone, and this is or benzophenone, and this is benzaldehyde, simple aldehydes. I answered this one because Mahinder put up this question to me that how can we name it. So I just asked him that we should do this practice in a video so everybody can listen and practice accordingly. So if you've done these mistakes with the methyl-ethyl issues and with these structures, also note these ones. Write few more like for propanol, butanol, pentanol, and all. This will help you understand more about aldehydes and ketones. Yesterday, I also compared to you one most common comparison of aldehyde and ketones comes in the case of the glucose and fructose. I hope it's all set for you. It was a revision and some answering the questions from yesterday. All right, you all must check it and ask me questions. I appreciate. If the questions are lengthy and you think you cannot explain or ask me properly in a text message, you can send me a voice message and I will answer here so everybody else, other students also can listen to it and also learn from it, right? Now we go to our today's topic, and today's topic is about the first aldehyde, the formaldehyde. Formaldehyde is the first aldehyde. Its structure is HCHO, or you can write C double bond O and then H. Right? By IUPAC rules, the formaldehyde is called methanol. I had told you this in my class yesterday that why methanol is called formaldehyde. All the aldehydes can be oxidized to carboxylic acids, and carboxylic acids have their name from their sources. Since those sources were identified in a very historical period when English was not the language of the world, however, Latin or Greek was. So the names were designed like acetic acid. If it is in the vinegar, then why not vinegar acid? Because by the time it was discovered, the name worldwide used for vinegar was acetum, and acetum means vinegar in Latin, so acetic acid. Ethanol, the 2-carbon aldehyde, is called acetaldehyde. Methanol is called formaldehyde for formic acid, and we have discussed the whole chart. Now, formaldehyde is the first aldehyde, which is the boss of the aldehydic family. And how we can make it, first I'll describe to you that what is it actually. Basically, formaldehyde is a gas. Okay, it is a gas. Many of you who know about formaldehyde must be surprised listening this that it's a gas, because you have seen it as a liquid. Okay, commercially available as a liquid. Commercially, it is a liquid. So I must tell you that hydrochloric acid, HCl, is also a gas. But what you have seen in the laboratory, it's a liquid. So if in class 9th you have prepared HCl, then you must know that the gas HCl is allowed to absorb in water. When the water absorbs HCl, enough HCl, then we call that liquid as HCl, hydrochloric acid liquid. Okay, but technically HCl is a gas. In the same way, formaldehyde is also a gas, but when it is prepared, the pipe, it goes into water, distilled water. Distilled water absorbs formaldehyde, and thus it makes a 40% aqueous solution. Now, the formaldehyde, if you will go to the market to purchase formaldehyde, you are going to call it formalin. In some countries, it's called formalin. In some countries, it's called fornolene. Now, formalin and fornolene is how it is available in the market. Chemists call it formaldehyde. These are basically 40% aqueous, excuse me for the spelling here, aqueous solution of formaldehyde. So when formaldehyde is prepared, the pipe goes into water, water absorbs the formaldehyde, and once the saturation is for 40%, more formaldehyde cannot be absorbed, hence there will be bubbles you will see, and now you can separate the formaldehyde and name it as formalin. Question remains, why will you go and purchase it, right? Yeah. So basically the oldest, the ancient use of formalin or fornolene is to preserve biological specimen. If you have heard about the mummies, how people used to preserve human skin once the people were dead. They used to soak them in formalin. Okay, if you go to a zoology lab, you will see snakes and birds, dead snakes, dead animals, still looking more like alive inside a can of water. Now that's not water; they are dipped in formalin, so they remain. I don't know the biological mechanism how this happens. Maybe we both should learn it. But the most common use of formalin or fornolene is as it is used directly as a biological specimen preservative. When we have a transplant, like for example, we have a kidney transplant. So kidney is taken out of one person. So how can you preserve the kidney before it goes to another person's body? Yeah, you put it into formalin. And in the operation theater, formalin is used like every time, all the time, you know. When you have appendix or you have any problem and they remove that organ or that tissue from you, they put it into formalin and then they send it for biopsy tests. So formalin is like purchased. It is also anesthetic, so don't smell it. There are other many commercial uses of formaldehyde. So this introduction, I think, will help you understand formaldehyde practically. All right. Now let's see how can we prepare it. Preparation. Okay. Maybe I told you or not. Alcohols are oxidized to aldehydes, and aldehydes are oxidized to carboxylic acids. Like all alcohols, when you oxidize them, right, they become aldehydes. And when you further oxidize aldehydes, they become carboxylic acids. So if you take methanol, it is oxidized to methanol. And if you oxidize methanol, it forms methanoic acid. Very simple. So this way, alcohols are number one source of aldehydes. So if you want, let's say, methyl aldehyde or formaldehyde, you need what? Methyl alcohol. Methyl alcohol, also called as methanol, right, can be converted into methanol. It's a very commonly asked question in the examination. Convert methanol into methanol. And there are many ways doing it. But on the industrial scale, a quick production is like the chemists want a quick production. So to obtain formaldehyde on the industrial scale, we use the vapors of methyl alcohol, CH3OH. I hope we can write CH3OH as C H H H, and we can see OH. Here, my friend, we need to remove hydrogen from methyl alcohol. The removal of hydrogen is called dehydrogenation. And this can be done if we mix methanol and air and pass through hot catalysts such as of copper oxide, mixture of copper oxide and molybdenum oxide as high as 300 degrees C. Now let me explain to you. Methanol is liquid, okay? Methanol vaporizes very easily. Let's say this is a container which contains methanol, CH3OH. It will vaporize on its own very easily, okay? And then this is a pipe which contain the mixture of these catalysts, the copper oxide and molybdenum oxide. Because you know, hydrogen has the ability to be absorbed into metals. It is absorbed more quickly in metal oxides and even more efficiently if you use a mixture of finely divided metal oxides, such strong metals such as copper and molybdenum. And if this is hot, right, this molecule CH3OH will surely lose its hydrogen. Let's say this hydrogen and this hydrogen, you know, if they they just leave this molecule as H2 hydrogen gas. All right. Now what's going to happen? This bond and the bond with the oxygen will be free. They will overlap over this sigma bond, right? And you will see H, C double bond O, and H plus H2. Right? Now H2 is gas. Formaldehyde is also gas. Now, if the mixture passes, if the vapors of methanol pass through the mixture of this oxide and heated, and then as an output, you will find out that there will be a mixture of two gases, methanol gas and hydrogen gas. And if we pass this pipe, let's say like this, through a water tank, this is suppose a tank of water, right? This is water, H2O. And if these mixture of gases go through this one, you will see the hydrogen gas is water insoluble, so it will escape. However, methanol will be dissolved in water to give you methanol solution. Now, the one I made is a general, but commercially there are different methods to check the concentration, 40% aqueous solution, etc., etc. So this is methanol. Guys, this is methanol. If these are both gases, okay, then they are mixed in the pipe. But we pass through water, so hydrogen gas, water insoluble, escapes out, and methanol is absorbed in water to give you 40% aqueous solution of methanol, which is called formaldehyde, or which is called formalin or fornolene. This is the industrial number one method to prepare methanol in industry is this. This is a little expensive because of the methanol. But the second method that we're going to discuss today is also from methanol, but this time oxidation. All right. So this is oxidation of methanol. This is dehydrogenation of methanol. Kindly refer to your textbook as well when you are making your notes. This is dehydrogenation of methanol. This is oxidation of methanol. All right. This method is slow and can be used in the laboratories. It's more popular in the laboratories. HCH and OH. This is our methanol. When we add enough oxygen to methanol, how we bring enough oxygen? We bring enough oxygen when we pour K2Cr2O7, potassium dichromate, in sulfuric acid H2SO4 concentrated. It releases lots of oxygen, which go react with methanol. Sorry, it's confusing. Methanol. Now here you can see the two hydrogens removed, making a pi bond and release as hydrogen. Here is different. Here these two hydrogens are released to combine with this oxygen to make H2O. All right. So I can use a pencil and show you that this hydrogen has affinity for oxygen. Right. So what happens when they go, these two bonds will make a pi bond here. So, all right. So it will become, you can see here, HC double bond O and H plus H2O. Again, it's a gas. It's also a gas because it's hot but then condensed, and then you make the methanol. Now methanol from methanol. If in the examination they ask convert methanol to methanol, I will appreciate if you use both methods, because the guy who will take the copies will obviously be more impressed. All right. So this is oxidation, this is the dehydrogenation. All right. Now, if you continue dehydrogenate this, okay, if you oxidize methanol to methanol, and if you further oxidize methanol, more oxygen, all right, and this more oxygen basically comes from potassium dichromate and sulfuric acid concentrated. Now, this will convert, this will be further oxidized, all right? The pi bond will stay, but the oxygen will bond with the hydrogen here, okay? The carbon basically, so you have a C double bond O and then OH. This is more commonly written as HC double OH. This is methanol, methanol. This is methanol, and this is methanoic acid, the first carboxylic acid. Methanoic acid, commonly called formic acid. Now I have a question. If we had taken ethanol, what could be the products? Ethanol, 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 ethanoic acid. Propanol, 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 propanoic acid. Okay, let's go here. Pentanol, pentanol. Then pentanol becomes pentanoic acid. If you want to go in common names, then methyl alcohol forms formaldehyde. Formaldehyde makes formic acid. So I hope you got this one, right? This is it. So this is mostly laboratory. Also industry, yeah, can be used, but this method is quicker in the industry compared to this one. And then there's no fear of getting any methanoic acid. Here there's always a chance of further oxidation to form methanoic acid. Now the third method, which is basically the cheapest one and the easiest one, is from calcium formate. Keep in mind, calcium formate is a mineral. Okay? It's inorganic. It's a stone. Okay? It's a compound which is basically a mineral. So HCOO O CaO C double bond OH. This is the structural formula of calcium formate. It is more easily expressed like this. Or you can write Ca and HCOO and 2. This is calcium formate. The two formate molecules are bonded to calcium. If we heat this compound in absence of air, it's called calcination. If we calcinate this compound, heat it at high temperature in absence of air, so if you can just focus over here, and you will find out if they combine CaCO and another O. So CaCOOO. What is this? CaCO3 Yes. And you can make calcium carbonate, which is, of course, solid. And this H goes here, you get H, C double bond O and H. So this way, calcium formate becomes formaldehyde. So, three methods of preparation of formaldehyde. One from the dehydrogenation of methanol with copper oxide, molybdenum oxide, 300 degrees C. Other is the oxidation of methanol with K2Cr2O7 and sulfuric acid concentrated, that's oxidation. And the third is by calcination, dry distillation, pyrolysis, cracking, all these names of calcium formate will get us formaldehyde. All right. So this method is common between aldehydes and ketones. If you just take here calcium acetate, okay, can I make calcium acetate? Yeah. Just compare this, okay, with this structure. CH3, C double bond O, O, and CH3, C double bond O, and O, and calcium. Now this is calcium formate, because formate one carbon. This calcium acetate, because there are two carbons. If it is also heated, dry distillation, CaCO3, all right, it will make a CaCO3. What are we left with? We left with CH3, C double bond O, and then this CH3. Now, if this is first aldehyde, this is first ketone, this is acetone, 2-propanone. So, calcium formate can make formaldehyde, calcium acetate can form acetone, and so on and so forth. All right, this is how we can prepare formaldehyde from three different methods. Now, after the method of preparation, we always jump to the physical properties, and most of the properties I have discussed with you already as introduction. You know that formaldehyde is a gas at ordinary condition. All right, it's a gas, it is not a liquid. Okay, so number one, it's a gas, and the one we see or purchase from the market is the 40% aqueous solution of HCHO. It's called formalin. All right, this gas will condense to liquid at minus 21 degrees C. That's the point of condensation of this gas. Very strongly soluble in water. That's why. How much soluble in water? 40%. Again, if this is an organic compound, why is it water soluble? Because it contains the pi bond, and the electron distribution is like that. The polar molecule gets a lot of attraction towards it. Okay, so it's a gas. It is available as a 40% solution. It will condense at this temperature, and it is fairly soluble in water. The smell of formaldehyde is very suffocating. So when you take formaldehyde into your lungs, of course, your lungs will not process, and you will feel suffocated. You know, this is so it's also you can say a poison for you. And if we condense it and then cool it, all right, it can make a solid, and that solid is called paraformaldehyde. Paraformaldehyde is ice type, also called glacial formaldehyde. And its formula is HCHON and then H2O. This is like you dissolve in water and then you just cool it down, you get a solid. This solid is known as the paraformaldehyde. There are two ways. One is cooling, other allowing it to evaporate. Most water will evaporate and some water will remain with it. So this is the physical properties of the formaldehyde. I hope you have understood the method of preparation of formaldehyde and also the physical properties and these equations involving the formaldehyde. Okay, I will also today mention some of its uses. So tomorrow we have an exclusive day for the chemical reactions of formaldehyde and the uses. You can check from the textbook. Okay. The uses of formaldehyde, I will recommend you to your textbook. But I will mention some to you here, okay? As I told you, formaldehyde is formalin. Fornolene is a 40% aqueous solution used as a preservative for biological specimen. I told you it is antiseptic, it is disinfectant, all right? I told you they both have similar purpose. And formaldehyde is used to make plastics. Bakelite. Remember bakelite? Bakelite from phenol. Also urea formaldehyde, using urea and formaldehyde. And also melamine. So three important plastics. One is bakelite. We have seen plenty of times in our syllabus. Other is urea formaldehyde. Very easy to make. Formaldehyde is a liquid. We pour phenol into it and it becomes plastic called bakelite. You pour urea into it, solid plastic called formaldehyde, and also melamine. Now melamine, I would like to discuss about it. If you go to your kitchen, you see lots of plates from white plastic. Some of them claim to be unbreakable, thick white plastic. Doctors recommend you to use melamine because unlike steel, they don't dissolve. Melamine is unbreakable plastic. And if you go to marriage functions and, like shadi halls, wagera, you will see that all plates are made from melamine. It's a unbreakable plastic, and it is very widely prepared from formaldehyde. So plastics are made from it. Some oils are made from it. Silvering of mirror. If I have taught you this in inorganic chemistry, you need a formaldehyde to deposit silver on a glass to make it a mirror. Okay, and the anti-polio vaccine and many vaccine use formaldehyde so that there's no bacterial effect on the samples. Okay, and formaldehyde can also be used to make some sort of explosives. So today's work, my dear friends, is the preparation of formaldehyde, physical properties of formaldehyde, and also the uses of formaldehyde. I will see how my students do it, and you will share with me, and I really like it when you guys share with me. Tomorrow, we will do the chemical reactions of formaldehyde exclusively. I hope you have got the entire lecture. Any questions, do share with me, and please practice the equations because they come in the examinations a lot. Thank you so much. See you next time in tomorrow's lecture. Bye.